Why is habit formation so complicated? How does the brain respond to and even recover from trauma? Why are patterns of negative self-talk so hard to beat? Hi, my name is Tarim Ali, and today I will talk about the concept that addresses these questions: neuroplasticity. Neuroplasticity is the capacity of neurons and neural networks in the brain to reorganize in response to new information, sensory stimulation, development, damage, or dysfunction. How does neuroplasticity work? To explain further, let's first discuss neurons, synapses, and neural networks. Neurons are the messengers of the brain, specialized cells that conduct impulses through the nervous system. They contain three major parts: a cell body, dendrites, and an axon. Neurotransmission is the process in which neurons carry information in the form of an electric charge that moves from one end of a neuron to the other end and then onto another neuron. Synapses are the junction where the axon of a sending neuron communicates with a receiving neuron across the synaptic cleft. The synaptic cleft is the space between the neurons. One single neuron may contain thousands of synapses. Neurons can form new synaptic connections and break up old ones, and you can remember this with the catchy phrases: neurons that fire together wire together, and neurons that fire apart wire apart. Neural networks are just series of connected neurons. One process by which neuroplasticity occurs is synaptic pruning, where weaker synaptic connections are eliminated and stronger synaptic connections remain and are strengthened by continuous activation. Interestingly, this process actually happens the most during adolescence. This might explain why the foreign language you learned freshman year of high school is long gone if you haven't used it since. Another process by which neuroplasticity occurs is axonal sprouting, where axons actually grow new nerve endings that connect with other neurons, strengthening existing connections and even repairing damaged ones. Axonal sprouting declines with age. Another example of neuroplasticity on a larger scale is cortical remapping, a phenomenon where a certain area of the brain will assume the functions of another area due to injury of the other area. It's remarkable how adaptable and resilient our brains are. In fact, a hemispherectomy is an intense surgical procedure where the diseased half of the brain is removed and the remaining part of the brain assumes the functions of the missing part. In selected patients, this is one of the most successful operations in stopping seizures. So, when trying to create a new habit, you're actually working to rewire and create a new neural network in your brain while simultaneously allowing the old one to break down. Say you want to stop snoozing your alarm, but are battling a neural network that has been strengthened by many a day of risking it all for an extra 7 minutes of sleep. Keep in mind that repetition is the key to strengthening a new neural network. This is why patterns of negative self-talk can also feel really hard to challenge, but it is possible with the knowledge of neuroplasticity on your side. Neuroplasticity is a beautiful thing that guarantees us all a unique brain of our very own, shaped by the life we've lived and will continue to live.